Welcome to the video tutorial for Chapter 1. Before we get started, I wanted to welcome you to BA 39 and give you a short definition of what Finite Math for Business will cover. Finite Math is a catch-all title for a collection of topics that are anything but calculus. The purpose of this course is to give a survey of mathematical analysis techniques used in the working world. You might also say this course gives you valuable experience at organizing information and then analyzing it. So let's get started. The first review topic of algebra is the order of operations. You'll see on the left-hand side that I've listed what the order of operations is for calculating an expression. The first thing you want to do is go inside the parentheses and complete that first. Then take care of any exponents. Then multiply and divide left to right, and then add or subtract. So in this problem on the right-hand side, you'll notice that there are parentheses. So I want to go inside and do that first. I'm going to write everything else out the same. -2 minus 3 minus 4 is a -1 squared plus 10 divided by 2. Then I need to take care of the exponents. Exponents are whatever a number is raised to. So my exponent in this expression is 2. So when I raise -1 to the second power, that's -1 times -1, and I get -2 minus -1 times -1 is 1, plus 10 divided by 2. Now you're going to want to calculate -2 minus 1 first, but order of operations says we need to multiply and divide left to right. So I'm going to start on the left-hand side and go to the right until I get to a multiplication or division problem. Here I have 10 divided by 2, so I can write this out as -2 minus 1 plus 5. Now I can add and subtract left to right, whichever comes first. -2 minus 1 is -3, plus 5 is a +2. And if you're unsure about this, you can always put it in your calculator. Sometimes the negative signs will throw you off, so if you're unsure, just plug it in. The next type of problem that we'll cover is called evaluating an expression. So I see here if a equals 3, b equals -2, and c equals -4, then I can plug in each of those values to evaluate the expression. So I have 2 times a, and a is 3, so I'm going to put 3 in parentheses, plus b is -2, put that in parentheses, minus c, so minus a -4. I highly recommend that you use parentheses when you plug these values in, because sometimes the negative signs can catch you off guard. So now I want to multiply and divide left to right, so I have 6 plus a -2 minus a -4, that's the same thing as adding 4, and then add or subtract left to right, so 6 plus a -2 is a +4, plus 4 is 8. The next type of problem that we have is expressing greater than or less than using symbols. So in the first example we have the phrase, x is up to 100 people. And if we wanted to create an inequality out of that, we could say that if x is up to 100 people, that means it can't go over 100 people, like it can't be 101 or 102. It needs to stay less than 100 people. It could also be equal to 100 people as well. So to create an inequality out of that, I have x is less than or equal to 100. So the less than sign points at the smaller number. Next I have two values, and I need to determine which one is greater than the other and express it using an inequality. So to do that, the hint is to convert each of the values to the same form before trying to compare them. So I'm going to convert them to a decimal. So in my calculator I will put 200 square root, and that gives me -14.14. I'll put this fraction into my calculator by putting 30 divided by 4, stick a negative on it, and that gives me -7.5. And so now I need to determine which one is greater and which one is less. In fact, this -14.4 is less than -7.5. So I need to write a less than symbol. It's not equal to it, so it's strictly less than. The next thing we're going to do is we're going to work with two polynomials. So we're going to be subtracting these two polynomials, and in order to do that, I need to subtract 4x squared plus 8x minus 9 from x squared minus 5x minus 3. In fact, when I subtract the second polynomial, I'm going to be subtracting each term in the second polynomial. So it looks like this. If I write it without parentheses, it looks like x squared minus 5x minus 3 minus 4x squared minus 8x minus a negative 9. Now when you subtract a negative number, it's the same thing as adding that number. So I'm going to add 9 onto the end. And now I have a large polynomial where I just need to combine like terms. So I notice that I have x squared here, the first term, and then I also have a negative 4x squared. So when we combine like terms, and in this case the like terms are the x squareds, when we combine them, we combine the numbers in front, or the coefficients, and keep the last name the same. I call it a last name. So this is like a 1x squared. So I'm going to take 1 minus 4 and I get negative 3x squared. Next thing is I can combine negative 5x and a negative 8x. Combine the numbers in front, the coefficients, and keep the last name the same. So I have a negative 13x. Lastly, I'm going to combine the constants together. So negative 3 plus 9 is a positive 6. Now multiplying polynomials is a little bit different. Here I have 3x squared times the binomial x cubed minus 4x. I'm going to be multiplying 3x squared times x cubed and 3x squared times negative 4x. That's called distributing 3x squared. Now when I multiply 3x squared times x cubed, I get 3x to the 5th power. I'm actually adding the exponents. Now I'm going to multiply 3x squared times negative 4x. So I multiply the coefficients in front. 3 times negative 4 is negative 12. And x squared times x, this is like x to the 1st power. This is x to the 3rd power. I can't combine any like terms here because I don't have anything with the same last name, so I'm finished. Now let's look at revenue, cost, and profit. Revenue is money coming in to the company. It's also called sales. So you can look at revenue as your sales dollars. Costs are money going out of the company. Costs could be fixed costs like rent and insurance. Another type of costs are variable costs. Now these are costs that go into the products that you sell. So if you're selling candles, it could be the glass jars or the wax that you use to make the candles. Those are variable costs because they vary based on the number of candles that you've sold. So what we're going to do is we're going to write expressions for revenue, costs, and profit. We need to make note of the fact that x is in thousands of items. So if x is expressed as 2, that means that there is actually 2,000 items sold. So let's show revenue in terms of x. We know the item price is $10. So if we multiply the price for one item times the number of items that have been sold, then we will get the revenue coming into the company. So I'm going to multiply 10 times x. Now to write the number of items sold, it's actually going to be x times 1,000 because x is in thousands. Like in our example, if x equals 2, then 2,000 items have been sold, or 2 times 1,000. So the revenue coming into the company is actually 10 times 1,000x, or 10,000x. Now let's calculate our costs. Our costs are our fixed costs, like rent and insurance, plus our variable costs, like the cost of goods sold, how much it costs to make the products that we're selling. So if we add those two things together, our fixed costs are $5,000, plus our variable costs, which is $5 times the number of items sold. Now the number of items sold is x, but actually it's X times 1,000 in order to get the actual number of items sold. So I have $5 times X times 1,000. So my costs are 5,000 plus 1,000x times 5, or 5,000x. So this is an expression for the costs. Now let's find an expression for the profit. When I calculate profit, it is revenue minus costs. So the revenue is 10,000x minus my costs. Now when I subtract this binomial, I need to make sure that I put it in parentheses because I'm subtracting each term. So minus 5,000 plus 5,000x. So if I subtract and combine like terms, subtract each of the terms, I have 10,000x minus 5,000x, that gives me 5,000x. And minus 5,000 goes on the end. So my profit is 5,000x minus 5,000. In the next problem, I'm going to be working with exponents. So the problem says the annual revenue in billions generated by the sale of movie tickets can be approximated by the function 8.19x to the 0.096 power. X equals 1 corresponds with 2001. Approximate the revenue in 2010. So X represents the years after the year 2000. 2001, X equals 1. 2010, X is going to equal 10. So I need to plug in 10 for X. So 8.19 times 10, put it in parentheses, raised to the 0.096 power. Order of operations says I need to raise this to the 0.096 power, take care of exponents, before I multiply it times 8.19. So the revenue in billions is going to equal 10 to the 0.096 power, which is 1.25 times 8.19. That gives me 10.22 billion. Now, since this is a word problem, it's important that we describe it as 10.22 billion. You can write out billion or just put a B. And since it's revenue or money, we need to make sure there's a dollar sign. So in the next problem, we have the gross federal debt, Y, in trillions of dollars, in year X is approximated by Y equals 1.16x plus 1.76, where X is the number of years after the year 2000. What year will the federal debt be 13.36 trillion? So I can see here that X is expressed in years and Y is expressed in dollars. The question asks what year will the federal debt be 13.36 trillion? So I am going to be looking for X. I'm going to be solving for X. And I need to make Y 13.36. So Y is 13.36 equals 1.16x plus 1.76. Now to solve for X, I need to subtract 1.76 from both sides. And I have 11.6 equals 1.16x. Then when I divide both sides by 1.16, I get x equals 10. Now you can keep it as 10 equals x, but normally we put our x's on the left-hand side. So this is the same as x equals 10. So now I need to make sure that I've answered the question. The question says, what year will the federal debt be $13.36 trillion? Well, the year wouldn't be year 10. X is expressed as the number of years after the year 2000. So actually my answer to this problem is the year 2010. For our last problem, we'll be looking at investments. And we'll be using the formula principal times the rate equals interest. For example, if I deposit $10,000 into an account at 5% interest, I just multiply the $1,000 times 0.05 to get the interest that I would earn at the end of the year. So in our problem, we have Mike invests $20,000 in two ways, some at 6% and some at 4%. He makes $1,040 per year in interest. How much is invested at 4%? So an easy way to set this up is by using a table. Here I'll put the 6% investment, and then I'll put the 4% investment, and at the top I'll put my equation P times R, rate, equals I for interest. Now I'm not sure how much Mike has invested in each of the accounts, but I do know that they add up to $20,000. So I'm going to put the amount that he invested at the 6% rate, I'm going to make that X. The amount at the 4% rate will be $20,000, which is the total amount invested, minus the amount he invested at the 6% rate. So you'll notice if I add these two up, it equals the $20,000. The rate for the 6% account is 0.06, and the rate for the 4% account is 0.04. Now if I multiply these two together, I will get the interest amount earned in each. So 0.06 times x is 0.06x. 0.04 times this binomial is 0.04, put parentheses around it, 20,000 minus x. Now the problem says that he makes $1,040 per year in interest for both accounts. So that means 0.06x plus the 0.04 times 20,000 minus x equals the total interest amount of $1,040. Now if I solve for x, I will find how much is invested in the account that earns 6%. So 0.06x plus, now here's where I need to distribute, so multiply 0.04 times both. So 0.04 times 20,000 is 800 minus 0.04x, and that equals 1040. Now I can combine like terms on the left, and I have 0.02x plus 800, that equals 1040. And from subtracting 800 from both sides and dividing by 0.02, I get x equals 12,000. Now I need to make sure that that answers the problem. How much is invested at 4% is the question. Well, I know that 12,000 was invested at 6% because I solved for x. To find out how much is invested in the account that gets 4%, I have to subtract that from 20,000. So I'll do it up here for lack of room. I have 20,000 minus the 12,000 invested at 6%, and that gives me $8,000. So that means that at 4%, Mike invested $8,000, and that answers the question. So that concludes Chapter 1's review. Watch this video again to look at the strategy for each of these problems before working on the worksheet.